Protons, neutrons, and electrons, right? Subatomic particles. So we need to know all about these. So I'm going to say what particle it is. So I'm making this table. And then we need to know its symbol, its relative charge. You guys know what I mean when I say relative? Yeah? No? Are we moving right now? Not relative to the Earth, but relative to what we are moving? The sun. You with me? So relative charge, it's a charge relative to something. We'll talk about that. Relative mass, the location in the atom, and attributes. It's all important, but this last one is the most important, I believe. All right, so let's start with the proton. Oh, heck yeah. Did you get a late note? Okay. Yeah, I'll need one. You can prop that door open if you want. Okay, what's the symbol of a proton? Symbol for proton is P with a positive, kind of like the exponent, right? And the relative charge is what? It's like the actual charge of a proton is 1.602 times 10 to the negative 19. Do you guys remember talking about that number? No? When we did scientific notation? 0.1234 all the way to 1602 coulombs. Do you remember that number at all? No? Oh, looks like you're not studying this stuff then. No. Just kidding. You don't have to know this number, but... So it's 1.602 times 10 to the negative 19. You don't have to write that. Don't write that. That is the actual charge. And we don't want to have to deal with that icky, yucky, icky number. And chemists don't either. Okay? The only people that have to worry about that number is physicists. Okay? So we don't have to. That's nice. Okay? Relative charge of a proton, we'll just say, is positive 1. Is that simple enough? Do we understand that protons are positive? Because they both start with a P, right? I don't know. That's not why, but okay. And the relative mass of a proton, is it a big number or a small number? Small. It's very small, like 10 to the negative 24 kilograms small. Tiny, right? We don't want to have to deal with that icky yucky number. So what number should we use? Starts with a W. What? What number starts with a W? Yeah, you said 1. That's right. 1. Sound it out. I'm just teasing you. Okay, yeah, 1. Are we good? Are we writing this down? We need to know this. Okay? And where's the proton located? Do we know? Yeah, it's the part that makes it positive, like Ernest Rutherford said, right? So this is, we don't call it the center, we call it the what? The nucleus. Thank you. Good? All right. Now, hopefully everybody knows what the attributes, what's so important about protons? What do they tell us? Actually, they don't tell whether it's negative or positive. Good guess, not quite. What do they determine? What element it is. So, number of protons determines the element. Huge. And this is how Dmitri Mendeleev, he come up with our periodic table. And if he first tried to organize it in order of mass, and it was pretty close, but there were a few of them that just didn't follow it, right? And until he put it in order of atomic number or number of protons, then it was periodic, and it was wonderful. Good? Okay, any questions on what a proton is and what do you need to know about protons? This is definitely a test question. Make sure you know that. Okay, then we got neutrons, which is N with a superscript 0. Why is it a superscript 0? Because they have a relative charge of 0. Because that's why we call it neutron, because they're neutral. Yeah? Okay, what's the relative mass? Any ideas? 1. It's the same as the mass of a proton. I mean, basically, not exactly, but close enough what we're dealing with, right? If we're going to round something times 10 to the negative 24 to 1, or just say it's 1, then neutrons are also 1, right? And is that something that's like, what? It's not really 1, is it? It's 1 something. And we'll talk about what it is later. And that's why we can actually use it on the periodic table. And it is used on the periodic table as 1. Okay? I didn't tell you what the units are yet, but we'll get there. In fact, we might have. Did we talk about AMUs in here? What? Okay, we'll get there. AMUs are like garbage units, but anyway, we'll talk about it. Where are the neutrons located? In the nucleus. We'll talk about later why they're in the nucleus. Okay? And this is why most of the mass is where? In the nucleus of an atom. That's most of the mass. Almost all of it. Okay? And what are the attributes? What did the number of neutrons tell us? It was on the quiz. The mass number, so determines the mass number, which is protons plus neutrons, right? So why don't protons determine the mass number? Because for a carbon atom, it always has 6. So that's not going to change for carbon. But the number of neutrons can change. And so this also determines what? It was on the quiz. Different isotopes. Determines the isotope. Okay. And we'll talk a lot about those today. And the last subatomic particle is the electron. You guys all writing this down? Because you're going to need to know this. The electron is E with a what's up top? Minus. Why? -1 charge. What's the relative mass? 0. Do they really have a 0 mass, guys? No, it's like 1/2000th of a proton. Well, what's 1 divided by 2,000? 0.000 something. Well, that's basically what? 0, right? And when we look at the periodic table, we don't include that when we determine the mass, or the atomic mass, or the mass number. Mass number is just protons plus neutrons. It doesn't worry about the electrons. Good? And where are the electrons located? Outside the nucleus. All right, now electrons, I think, well, they're all important, don't get me wrong, but I think they're the most important for this class. Why? What do they determine? Two things. The charge. Why don't the protons determine the charge? Because they have the same number no matter what element they are, right? That doesn't change. Did the number of electrons change? Did we stick tape to the wall here in this class? Oh, probably the only class I didn't show. Why? Because we're quiet in this class. And so when I ask questions, nobody says anything, and nobody asks any questions. And so we don't go further. We just call it good. Do you guys know what opposite charges do? What do like charges do? Let's find out, shall we? Here we go. Did I ask this question before? I think, are you sure? Okay, so you guys can do this at home if you want. Get a piece of tape about this long. Doesn't have to be this long, but this is good enough. And I fold the end over so I can grab it without sticking to me, right? And I'll just stick this on the wall, or you can stick it on the table. That's fine. Get another in about the same length. Doesn't have to be exact. I'm going to fold the tab over again so I can grab it. I'm going to stick it right next to it somewhere. Then I'm going to take this off. Then I'm going to take this off. Not cool? Yeah. Oh. So what does that tell us? Same charge? Same charge. How do we know that tells us it's the same charge? Same charge repel? How do we know that? That says in the science book, when they just told us. So but how do we know? There's no magnets here. So watch. What's on the outside of an atom? The electrons. And this tape is stuck to this wall. Is there electrons on the outside of this wall? Or this whiteboard? Yeah. And when I take this off, what am I doing? I'm ripping some of those electrons off. This is negatively charged. Ripping some of those electrons. This is negatively charged. And how do we make it like charged? Or sorry, opposite charged. How do we make it opposite charged? Stick it right on top of it. Now it's like neutral, right? Now this one's going to pull off the electrons of one. This can be negatively charged. This one's negative. This one has less electrons, so it's positive. Whoop! Whoop! Isn't that cool? Oh, that's like magic, huh? That's because I'm a scientician. That's a new word I learned. My nephew made it up. All right, we good? Okay. So what are you saying? Electrons are free to move, right? You can take them, and that's why they determine the charge. What else do they determine? Chemical and physical what? Why? It determines how it's going to react. Why? Because they're the only thing that changes during a chemical reaction. Only part. Isn't that cool? So we change those, and Something happens. So the electrons determine the properties. Did we talk about electron? No, we didn't yet. Okay, we'll get there. Well, I teach 3 different chemistry classes, so I don't remember which chemistry class I didn't teach it to. So, oh, we're kind of all the same level, and then this one kind of slows down because we're in high school, so it's a little bit slower paced. Okay, we good? Do we have this down? Memorize this stuff. Not just memorize it, but know it. Understand this stuff. Okay? Understand all of it. Know all of it. But make sure you know this is a good test. Oops. That's a great test question right there. Great test question. All right, let's move on. Okay, now we're going to just give some definitions. Let's talk about the protons. The number of protons determines, what do we call this? The atomic number, right? Or number of protons. Good? How many protons does oxygen have? Everybody look, there's a periodic table up there. It's the atom number, the atomic number. Do you get why we call it the atomic number? It's the number of the atom, or number of the element. It has 8 protons. Oxygen, if an atom has 8 protons, it's always oxygen. Always. No exception. Isn't that cool? We are going to have exceptions in this class, but that one, there's no exceptions. So how many protons does gold have? AU. 79. Now that we say 79, you can find gold because they're a number order up there, yeah? Okay. We good? That's a test question, guys. Can we do that? Yeah, please ask only that question, right? And then we got it? All right. Okay, the next thing is the mass number. And I'm not going to give you a definition this time. I'm going to give you an equation. Mass number equals number of protons plus number of neutrons. Why is that? Let's make sense of that. Why is the number of protons plus the number of neutrons? Use this table to guide your thinking. Hope everybody's thinking about it, because I want you to come up with the answer. As soon as you know it, as soon as you have an idea, then let me know. Why is the mass number equal to the number of protons plus number of neutrons? Yeah. What's the relative mass of these guys? Ones. What's the relative mass of electrons? 0. So the mass is just number of protons plus number of neutrons. If protons has a mass of 1, neutrons has a mass of 1, and it has 1 proton, 1 neutron, what's the mass? 2. But if it has 2 protons, 2 neutrons like helium, then it has 4. You with me? Make sense? All right. Okay, now let's get into isotopes. An isotopes are atoms with the same number of protons, but different number of neutrons. What do you think isotopes are classified as? How do we differentiate isotopes? By their what? Their mass number. Because if it has different number of neutrons, it has a different mass. But it has the same atomic number, right? And we'll give you an example of these. But does that kind of make sense, everybody? Yes or no? 5 if it does, 1 if it doesn't. It doesn't have to. Does that make sense? It doesn't have to. If you don't even know what my question is, then don't put a 5. So my question is, isotopes are differentiated by the mass number. Because not the atomic number. They're going to have the same atomic numbers, right? Isotopes will have all the same atomic number. But they all have different mass numbers because they have different number of neutrons. The neutrons plus protons is the mass number. Good? All right. So let's do an example. Let's do an example that maybe we've heard before. I don't know. I'm just saying maybe. So we got hydrogen 1. And we either call it that or we say hydrogen 1. And what's the 1 tell us? That's the mass number. But we also have hydrogen 2. Hydrogen 3. So we have 3 isotopes of hydrogen. The majority of hydrogen is hydrogen 1. And we have a special name for this. Call it protium. Why do we call it protium? Yeah, but why did they? There's a reason. If it has a mass number of 1, how many protons does hydrogen have? Look at the periodic table. 1. How many neutrons does hydrogen 1 have? 0. Because its mass is 1. That means protons plus neutrons is 1, right? If it has 1 proton, 1 plus what equals 1? Everybody, 1 plus what number equals 1? 0. We know this, right? Okay. And so basically, protium is just a proton. That's all it is. A proton with an electron buzzing around it. And most of the time, that electron is ripped off anyway. Okay, we'll get there. Hydrogen 2 is called deuterium. Because deux means 2, right? In French or something? Deux. I don't know. Okay. And what do we call this one? Hydrogen 3. Tritium. Has anybody ever heard of that isotope? Where have you heard it? Of what? Atomic bomb? Not quite. Atomic bomb, we use uranium. No? Well, it's probably in there, but that's not where it's from, okay? Have you ever watched Spider-Man with Tobey Maguire? Spider-Man 2 with Doc Ock? What did Doc Ock, what was he trying to do? Create energy, right? Energy, but he did create a sun, a small sun. He wanted to create energy so we can power the whole world, clean energy, right? Great purpose. But then he turned evil with those arms, right? And what did he use to do this? Tritium. Well, he had to steal it the second time because they wouldn't give it to him because it's so rare. It's like less than 1% of all hydrogen is tritium. Okay? So he had to steal it. And he made a sun out of it. You remember that part? Who's never seen that show? Oh, looks like we have homework. No, yay, I love that one. Okay. No, I'm just teasing. But, so that, do you guys like those kind of shows? You know? You hate them? Oh, so she's not a science lover. No. It's science fiction. That's where it all comes from, actual science stuff, right? And then they just, okay, we don't know exactly what's going on here, so we'll just kind of, yeah, this is cool, right? Anyway, so can we actually make a sun with tritium? We haven't ever done it yet, but how do we know it can happen? Because where does this happen, guys? In the sun, in the stars. It happens right now as we speak. It's happening. Okay? These are coming together and they fuse together and make helium. And then helium and hydrogen fuse together and make lithium. And so on until it gets to iron. And then the star explodes. And then we get some of the heavier elements. Really? Really? Is that real? As far as we know, that's what it is. Okay? All right, and you guys know you're just stardust, right? Do you know that? Did we talk about this? And you guys are stardust. Isn't that romantic? Ah, it's so nice. Kaylee doesn't appreciate it, but I'm just teasing. All right, so those are different isotopes. I'm going to show you the symbol for an isotope, and you need to know this, ladies and gents. Okay? The A is the mass number. So that's the number of protons plus the number of neutrons, yeah? The Z, that's not a 2, that's a Z, represents the atomic number. And the C represents the charge. And the X represents the element symbol. On the homework today, on the worksheet today, you'll have to be able to do that. You'll have to be able to write this symbol. So if we write this isotope symbol for these isotopes up here, what's the hydrogen 1 going to look like? H is the element symbol. What number goes on top? What number is the mass number? 1. What is the Z, the atomic number? 1. And what's the charge? Well, 0 most of the time, until it reacts with something. Okay. What is the symbol for H2? What goes on top? What goes on top? What goes on bottom? 1. It's still hydrogen. Still has atomic number of 1. What about H3? What goes on top? What goes on bottom? You got the idea, guys? Okay. So from there, can you determine how many protons, neutrons, and electrons they have? Let's try it. In fact, I'm going to give you something real quick. The charge, I'm going to have to figure this out because I don't have it stuck in my brain yet. So this is 9 minus, yeah, okay. Here's how you find the charge. Atomic number minus number of electrons. And that's how you get the charge. Let me make sure that's true. Atomic number minus the number of electrons. Yeah, that's it. Y'all have that, Kaylee? I know you're bored out of your mind because this is so wonderful and you don't like wonderful stuff. Be with me. Sit up straight. Be focused. Okay? It's a lot easier to learn that way. Okay, should we try this? All right, let's do Mg 25 2 plus. I want you to determine how many protons, how many neutrons, and how many electrons this isotope of magnesium has. Can you do it all by yourself, or should we do this one together? What do you think? Try it by yourself, and then we'll do it? Okay. Yeah, see what you know. See if you could do this. I bet you can. You're going to have to use the periodic table, though. And if you need to go get one of those green periodic tables on the bed of nails, you can. Or you could just look back. I don't care. And if you guys want to start getting a periodic table each day, might be useful. Or would you guys want me to print your own so you could just have it with you always? Would that be good? Do you guys want it regular paper or cardstock paper? Cardstock? Okay. I will do that if I have time in class today. I'll do that. Who needs more time? Nobody? Okay, how many protons does this have? Is it 2? Is it 12? How many protons does magnesium 25 have? How do you tell? Why is it 12? Because that's the atomic number for magnesium. And the atomic number is the number of protons. Yeah, always. So can we write a 12 down here, guys? Yeah. So if they don't give us that number, we can still know. We look at the periodic table, find magnesium, and it is number 12. Does everybody get that? Because you're going to have to know that. Okay? So 12 protons. How many neutrons? Do we know the equation for number of neutrons? Number of neutrons equals mass number minus atomic number. If you want to remember that, you can. Or we could just subtract the bottom number from the top number on this symbol. 25 minus 12, because this is the mass number. This is the atomic number. Good? And what do we get? 13. Are you with me? And how do we find the charge? Charge equals the atomic number minus the number of minus the number of, hold on. Atomic number. Yeah. That's what it is. The charge is equal to the atomic number minus number of electrons. So we can use this equation, right? What's the charge? Positive 2. Well, it says 2 plus. Why do we write it backwards? Because that's the way they did it, and that's the way it stuck. So that's how we write it. But it means plus 2, right? Is equal to the number of the atomic number, which is 12, minus the number of electrons. We'll call E, because we don't know how many there are, right? Can we solve for E? Yeah, let's add E to both sides to get rid of the negatives, right? And subtract 2 to both sides, and we got E is equal to what? 10. That's one way to do it. Anybody thinking, oh my gosh, some algebra? I don't want the algebra. I just want to do it a different way. Anybody want a different way? What? That's algebra. Minus, right? That's math. Well, I guess we can't do it without math, I guess, because it's numbers, right? But here's less algebra if you want it. You don't have to, but here's another way. This is the way I used to always do it until one of my students showed me this. One of my students showed me this. I've been teaching it for 15 plus years. And one of my students showed me this. Thank you. So, but this is how I always did it. We have a charge of positive 2. Does that mean we have more protons or more electrons? Oh, more protons, right? How many more? 2 more. If we have 12, that's 2 more than how many electrons we have. So we have 10. That's the way. Is it the same thing, just in reverse, just in your head? It is. The same thing, just in your head. Good? But one of my students was a little bit smarter than me and come up with that. I don't know, maybe she read the book. Was that in the book? No, that one's not in the book. Amigo!
Amigo!
I bet he does it. See? Now I want you guys to straighten up your attitude. That's good. Oh! Talk to Miss Foster. Ask Miss Foster. There we go. There's the big guy for you. Don't disrupt us, Victor. Okay. Are we good? That's because we're amigos, guys. That's why. We have the same name. What do we call it? Hey, Victor! Oh, let's see. Taquero? Yeah. Taquero. He's my namesake. That's what it is. Okay. I have a special name for that. Okay, whatever. All right. We good? But he hates my name. So ask him, he'll tell you. Okay, Mr. O'Brien. Get on with chemistry because this is way more interesting. Is that what you're saying? All right, let's do an example test question, shall we? Well, this is an example test question right here. You have to know that, how to do that, okay? Here's another one. Let's say we have 4 elements, or 4 isotopes. 4 elements, I should say, 4 atoms. And this one is 14, 12, 13. And let's say we have 6, 7, 8, and 6. Out of these atoms, Which two are isotopes will be a good test question. And if we call this A, B, C, and D, your answer would be, which two are isotopes? Is it A and D? That's a good, great question. Is it A and D? Why is it A and D? Same number of protons, different number of neutrons. Oh, is that top number the number of neutrons? No. How do we know it's a different number then? Because that's protons plus neutrons, right? And the protons don't change, so just the neutrons change. Yeah, that's it. So these two are isotopes. Are these two isotopes? No, because they have different number of protons. Good? Let's do another example. Not of that one, but of the isotopes. Let's say we have arsenic 75 with a 3- charge. How many protons, neutrons, electrons do we have? Everybody do this. See if you can do this on your own without any help. Maybe you already did it last time. Okay. Okay, who needs more time? Okay, another 30 seconds or so. What? Remember, you have to use a periodic table for this, right? Is it to your advantage to become familiar with these elements? Yes. That way you don't have to search where in the heck is that one, right? Kind of just know where they are. You don't have to know exactly where they are, but know what they're called, what their name is, what their element is, and about where they are, what kind of element they are. Metal, metalloid, non-metal. Because we know where they are, right? No, we didn't learn that yet. We didn't learn that yet. We'll get there. Okay, how many protons does arsenic? 33. So the atomic number is 33 to arsenic, right? How many neutrons do we have? 75 minus 33 is what? 42. Are we good? Any questions so far? Okay. And how many electrons? 36. Are we good? Questions? If you have a question, please ask it right now. Not later. Not. Okay. Make sure you ask it if you're not sure. If you don't understand where we got these numbers. Okay, ladies and gents, I gave you a whole worksheet of practice for this. You can answer number 1, 2, and 3 on your own. But let's do this first one together. Let's do the second one. No, that's okay. We can do the first one. Okay. Says right here we have, chromium 58 and chromium 63. So we got to know number of protons, neutrons, and electrons. And right here in this top left corner, I want you to write the isotope symbol. Everybody understand what that is? This is the isotope symbol for arsenic 75. Okay? All right. So, how many protons does chromium-58 have? Look at the periodic table. What is it?
24.
24, because its atomic number is 24. Okay, so can we write the isotope symbol yet? We can. What's the top number? 58. That's the mass number right there. And the atomic number is 24. There you go. We can't do this one yet. Or can we? How many protons does this one have, guys?
24.
It still has 24 because it's still chromium. So we would do that one. I didn't save room here. So let me add room. This one would be chromium-63. Are you with me? How many neutrons does chromium-58 have? You should just subtract. What is it?
34.
34? How many does chromium-63 have? Let's see. 739? Yeah. Good. And how many electrons do they have? Do you see a charge on chromium-58 and chromium-63? If you don't see a charge, what is it? 0. If the charge is 0, or if it's neutral, how many electrons do we have relative to how many protons? Same number. You have the same number of positives as negatives, make 0. You with me? So what's the number going to be? 24. 24. Do you get how to do this?
Yeah.
Okay. You want me to get you time doing it so we don't have homework? Kenneth, and if you're doing this here, we don't have homework. And you got an assignment all done. Oh, time to clean up. Any questions on the ones on the board? No?